For the last few years, AI has mostly lived behind glass. It writes emails, summarizes PDFs, generates images, and answers questions. Useful? Absolutely. But it still can't do anything in the real world. In 2026, one of the biggest shifts is this. AI is leaving the chat box and entering the physical world. That shift has a name: physical AI. Not AI that talks about the world, AI that can see, understand, and act inside it. To see why this matters, think about the difference between knowing and doing. A normal AI can tell you how to set up a room for filming. It can list the gear, explain lighting, warn you about reflections. But it can't move the tripod. It can't adjust the softbox. It can't walk in and say, the light is too harsh, rotate the setup 30 degrees. Physical AI is when the system can do that. So what makes physical AI possible now? 3 things are coming together: better perception, better decision-making, better control. First, perception. A physical system needs to understand what's in front of it. Cameras, depth sensors, sometimes touch. But sensors alone aren't enough. The hard part is turning pixels into meaning. A cup isn't just a cylinder. It's full, fragile, easy to spill. A cable isn't just a line. It's a tripping hazard. Modern vision models can detect objects, estimate depth and distance, track motion over time, sometimes infer properties like soft, slippery, or heavy. That's seeing versus understanding. Second, decision-making. Now the robot has to choose actions. And the world is messy. Lighting changes, objects move, people walk in, things slip. You can't hand-code rules for every situation. So the modern approach is teach the system to predict and plan. In 2026, you'll hear this term a lot: world models. A world model is a learned simulator in the AI's head. Not perfect, just useful. It helps the AI ask, if I push this box, where will it slide? If I grip here, will it rotate? If I step forward, will I collide? So it plans before it moves. Prediction makes everything safer and faster. Third, control. Turning decisions into movement looks simple, but it's not. Robots move with motors, joints, friction, and limits. Even picking up a bag is tricky. How much force? Where do the fingers go? What if it's soft and changes shape? What if it's heavier than expected? So physical AI needs control policies for continuous motion, not just left or right. Move 2 centimeters, rotate 5 degrees, ease grip slightly. That's why robots train in simulation first. Millions of attempts, drop objects, collide, fail, try again. Then transfer to the real world, sim to real. Still hard, but improving fast, and a big reason 2026 is different. So what does physical AI look like in practice? In 2026, you'll see it in 3 places: warehouses and logistics, robots that can pick many different items; manufacturing and inspection, systems that spot defects and adapt to variation; service and messy environments, hospitals, hotels, kitchens, labs. And yes, humanoids are part of this story. But the real story isn't the shape. It's the stack: perception, planning, control, plus safety on top. Because once AI can act, the cost of mistakes goes way up. A chatbot can hallucinate, and it's annoying. A robot can hallucinate, and it can break things or hurt someone. So physical AI systems include guardrails like collision checking, speed limits near humans, uncertainty detection, fallback behaviors when confidence is low. In 2026, move fast and break things doesn't apply. It's move carefully and prove it works. So here's the big idea. Physical AI is not one model. It's a system, a pipeline that connects sensing to understanding, to predicting, to acting, to checking, to correcting. And that system is getting good enough to leave the lab. That's the shift. We're moving from AI that helps you think to AI that helps you do. Thank you for watching. What physical task would you want AI to handle first? If you want more breakdowns like this, subscribe, and I'll see you next time.